All right, well, let's take a look at the results of the exam. I have those here for us. This may be hard to read from where you're sitting. I can summarize things here for us. So everything in blue is the first exam, everything in orange is the second exam. And I don't know if you remember when we talked about the first exam, the class average was an 84, and we had this thing called a standard deviation, which I said was very small, which was good to see. So on exam 2, our average went from an 84 down to a 78.8, and our standard deviation grew, which means students didn't do as well, and we started to see some separation between students, right? Does that kind of make sense? Yeah. So, you know, I thought this was really good. This is more on par with what's normal in a class right here. So the average student got a high C, which is about, you know, that's what average means, right? Average is a C, B is above average, A is exceptional. So that's kind of the data. We had 5 A's, 9 B's, 4 C's, 2 D's, and 3 non-passing grades. Well, a D doesn't count in college level course, so these 5 are not passing the test, and then the rest were. And I guess I was trying to find, I like to do this where I show the highest score on exam 2 all the way down to the lowest score on exam 2, and then you put that student's exam 1 grade with it, and so you can kind of see if the student improved or went down or stayed about the same. So I don't know. It's hard to read this. I guess my concern would be if you're down here and you were down here on both exams, that would be a concern for me. You know, like for example, this student on exam 1 went from a 56 to a 92. So that's a dramatic improvement. And then we had students go the other way, where you go from like an 81 to a 51. So it's hard to look at that and know what's going on, but that's the data. Let me just pass these around. If you haven't picked up your exam, just grab yours out of there. The grades are not on the exams. All you have to do is take the total number of points and subtract it from 100, and that's your grade, and that should be on Canvas already. Who else needs it? Okay, anyone else? Just grab yours out of there. Were there any questions or concerns or comments about the exam?
I guess, like, for number 5, I guess I didn't really understand. Well, I guess I didn't understand how to set that up.
Number 5. Okay, yeah, so on number 5, you're looking to find a linear equation that describes what's going on there. Mm-hmm. So we talked a little bit about this. It's using a linear equation, something that would look like this: y equals mx plus b, where we basically need to figure out what m and b are to figure out to model this real world situation. So the way I did it is it says you're supposed to come up with an equation that gives Heather's pay in terms of her sales. So what I did is I said, okay, her pay is going to be equal to, well, how much does she get paid every week?
400.
400, so that's what we call the fixed. Okay, that's 400 plus, and then she makes 15% of what she sells. So I put here for my M 0.15 as a decimal, and then you could use X here. I used S for sales, and that's my linear equation.
So I guess when I read it, when it said 400 plus 15%, I assumed like 15% to the end. Like
you could do it the other way. You could put 400 plus, but the variable needs to be on the correct.
So that variable should have been with the 15.
Exactly. Yeah.
Okay.
So if you put the 15, if you put the variable on the 400, then
that's what confused me. No,
yeah.
That's what confused me with B. Well, I got B and C right.
Yeah.
That was just
So some people didn't get the equation but got the other ones right. So, yes.
How do you do C?
Part C, how much clothing would, what did you use for, did you get your equation right on that one or no?
Yeah.
You did. What did you have for your equation? What did you write down? You put x equals 400 plus 0.15. Did you put a variable here? No. Okay, that's probably why this isn't going to work. Because what you're supposed to do, let me go back to this. Okay, this right here, you could have got the same, like correct answer if you would have put a variable on this. This would be, I don't know, let's just put m here, all right? This says she's going to make $400 plus 15% of whatever she sells. Part C says how much does she sell, so what is this number to make that number 1,000? To make this 1,000, what does this need to be? So you would set up the equation 1,000 equals 400 plus 0.15 m, or whatever you call that, and then solve for m. So subtract 400, get 600 over here, divide by 0.15. Does that make sense? Yeah. Okay. Yes?
6B.
For B, all you're doing is plugging in 2,000 in for her sales.
Six questions.
Oh, sorry. Yeah. Okay, so for number 6, part B, this was that mixture problem. So you have 30 gallons of pure water is added to 8 gallons of a mixture that's 35% hydrochloric acid. And when you mix those together, you should get a total of 38. I don't think anyone missed that. 38 gallons, right? But the question is, what is the concentration of this? How much hydrochloric acid is in here? So what you have to do is figure out how many gallons of acid are in here and how many gallons of acid are in here, and that would be the total number of gallons of acid here. So there's 0 gallons of acid from here because it's pure water. Here, to figure out how many gallons, you have to do 0.35 times 8, which gives you understand? 0.35 times 8, that gives you 2.8 gallons. So when you mix these together, you have this plus this, which means you still have 2.8 gallons. And then to figure out the concentration, you have to take this many gallons, 2.8, that's how much acid you have, and divide it by the total amount of liquid in the container. And when you do that, you should get something like 0.0736. Move the decimal over, somewhere around 7.36%. A lot of people did that backwards, or did some, like flip this over, or did some other things. So, does that make sense?
Yeah. What I did was, actually, when you say like 8 gallons of water has like 35% hydrochloric, and when you mix these 2 gallons, the concentration of the acid in the mix of the 2 gallons, 2 different amount of water, will vary like in a way, because we're talking about concentration, right? So what I did was, if it is 35% for 8 gallons, how many percent would it be for 38 gallons?
Got you, okay.
So when I did that, what I got is like multiply 38 times 0.35 over divided by 8 gallons.
So you set up like a proportion.
Proportion,
yes.
And then what I got is 1.6625%, which is, I don't know.
Yeah. So yeah, the problem with that is that doesn't bring this water into the problem at all, right?
Proportion, right? Isn't it? The question was how many percent of hydrochloric would be in the mix of the 2 waters. So
yes.
If it is like 35% for 8 gallons, when you mix the 2 waters, how many percent would be the concentration of the acid in the mix, right?
Well,
so, for me, that's a proportion question.
So if I had asked you, if I had said 8 gallons of 35% hydrochloric acid, right? You have this. What would be the concentration in 38 gallons of hydrochloric acid? It would be the same. It would be the same percentage, 35%. Like if you're just making this go from 8 to 38, but not bringing in the water, the water dilutes the acid, so you shouldn't have as much. So if you don't incorporate that into the problem anywhere, then you're not gonna Does that make sense?
That's where the trick is.
Yeah.
That's why it's
Yeah. I did a few of these in class. Remember, didn't I ask you to do one too?
yeah, we did.
Yeah, I think
do
you
remember,
did,
but
so.
Still, when you do proportional, it's just confusing.
Yeah, so this problem is not really a proportion problem. Okay, who else needs their exams? Let me just pass these. Let me see. Paris, Brianna, let's see. Alyssa? Alyssa, there you are, okay. There you go. And David, Davis, Timothy, there you go. And Gloria. And Miranda. Okay. All right, Miranda or David, no? Okay, so we've looked at the averages. I was pleased with that. Like I said, a 78 average is still a high C, almost a B for the class, so I think we're in good shape. We still have 3 more exams to go, which is kind of mind-boggling how we're going to do that, but that's what we're doing. We don't have to? Okay. We are going to continue now, and I said we're going to have to kind of pick up the pace a little bit. We are going to be talking about factoring. And factoring is one of those things where if, you know, maybe in high school or some other class that you were in, you kind of got it, you understood it, you're good to go. If that's your situation, I'm not here to confuse you or to try and make you learn a different way. So if you're comfortable with factoring, stick with what you've got. Because realistically, factoring should take weeks and weeks and weeks to do, all right? To get really good at it, we're going to kind of cover it in like a day. So let's first talk about factoring. So let's say I had this problem right here, and I said, 2x, and then I put parentheses, x squared minus 3x plus 1, and I asked you here to expand this. Okay, or if you don't like that, I ask you to multiply, all right? So if we were asked to do that, what we would do is this thing called distribution. And we would take the 2x and we would multiply it through to each of these terms, and we would get some new answer, right? So let's go ahead and do that. If we multiply that through, we should get 2x cubed. What's my next term?
6x squared.
Minus 6x squared. And then finally, plus 2x, right? Okay, so that's called expanding or multiplying. And we did a little bit of that in the very beginning, like earlier in the term here. This is not factoring, okay? The direction from going from this to this, is called expanding. What we want to be able to do is go backwards. We want to be able to take an expression like this and turn it back into that, all right? That's what we want to be able to do. And this process of going backwards is called factoring. And the main thing that happens when you factor something is that instead of having pluses and minuses between things, what you have is somewhere you have a multiplication. So it's turning additions and subtractions into some sort of multiplication. I'll give you another example. Something a little more challenging. How about like this? 2x plus 1 times x minus 3. Let's expand this, okay? So to multiply those, you would do that FOIL thing, right, that we've discussed. So let's go ahead and do that. We go here to here, we get 2x squared. Here to here, we get, what, minus 6x. Here to here, we get plus x. And here to here, we get minus 3, right? But there we wouldn't be done, would we? What would we need to do? Combine like terms. So we would have to put these two together. So we would get a final answer of 2x squared minus 5x minus 3, right? So that's how you expand. We want to make sure we know how to go back to this, okay? And that's our factoring piece. all right? That's not as easy to do, to do the factoring, all right? So we'll work on that. We'll talk about how to do that. Let's do another example. How about this one? How about x plus 2, x minus 2? What would happen if we multiply those together, expand those out? So what would we get here? X squared, and then here we would get minus 2x, and then the middle one plus 2x, and then the final one minus 4. And now if we clean that up, these middle pieces go away, don't they? So you wind up getting x squared minus 4. So we are going to want to be able to go back from here to here. And some of you probably already recognize that. Does anyone recognize what we call this? There's a special name for it. Difference of squares. Now we'll talk about this, but this is a very special form. When you see something like this, there's a special way that it factors. So, okay. Does this make sense? What we're trying to do? We haven't talked about how we're going to do it, but do you understand what we're trying to do? Yeah? Okay, now you might ask yourself why you would ever need to factor. Like, what's the purpose of factoring, right? Maybe? Yeah? Or do we not care?
No, I want to know.
Okay, so we know, think about this right here. When we have, let's say something like this, y equals 3x plus 1. We know that if we graph this, this is a line, right? And one of the things that you can do to graph a line is you can find the X and Y intercepts, right? So if I ask us here to graph this, to find the X intercepts, what do? Replace y with 0, right? So if I replace y with 0, this becomes this equation, which is relatively easy for us to solve. We can just move things around, solve for x, and we're done, right? So then I'll be able to tell you where the graph hits the x-axis. So this is something we can do, and it doesn't require anything special other than replacing the y with 0 and solving the little equation here. However, what we're going to do down the road after we finish the factoring is we're going to try and graph something that's not a line, something like this. So we're going to try and graph this equation. Now this, we haven't talked about, it turns out to look like what's called a parabola, which is like a U-shaped graph. It's curved. Okay? This thing still has x-intercepts and y-intercepts. So if we are asked to find the x-intercepts for this, where this thing hits the x-axis, the first thing we would do is the same thing we did with the lines. We'd replace this y with 0. Okay? So if we replace the y with 0, we have this. Agreed? Now, how do you solve this for x? See, this is different. This is not linear. You can't just like move numbers over, divide. You see, you can't get x by itself easily because there's actually two x's in here, and one of them's squared and one of them's not. So you cannot get x by itself equal to something easily. So the first step that we need to do is take it, I put it intentionally, it's this. Do y'all see that? That's the same thing? So what we would do is we'd factor it to this, and then what you wind up doing is you take this and set it equal to 0, and then you take this and set it equal to 0 separately, and you get two answers. And those will correspond to the two places where your parabola will hit the x-axis. So to solve this equation, we're going to need to be able to factor. Okay? And that's the general idea here. And any equation you ever get that's not linear anymore, you need factoring in order to set it to 0. So it's just a skill that we need, all right? I hope that somewhat makes it valuable in some sense, I don't know. All right, so let's go ahead and talk about factoring. I'm going to give you a procedure to follow, all right? So how to factor. And this is pretty much for anything, all right? For anything that you're ever presented with, here's the steps that you take to factor. First step is factor out what we call the greatest common factor. also known as the GCF. Okay, now I should put here, if possible, because it may not even be possible. There may not be a greatest common factor, all right? But that's the first thing you always want to do. And if you don't know what a greatest common factor is right now, don't worry about it. I'm just going to give you the steps, and then we'll go through some examples, and we'll go through the procedure, all right? So the first step, we pull something out if we can. Second step, count the remaining terms. Count the remaining terms. So after you've pulled something out in the first step, if you were able to, whatever's left, you want to count how many terms there are. Now, when we say terms, do we all understand what we mean by terms are anything that's separated by pluses and minuses? So these are, like this. How many terms are here?
2.
Well, we have we have an addition and subtraction, but how many terms are there? 1, 2, 3. 3 terms, okay? So we want to count our terms on the next step. And then, once we count our terms, there are 3 different possible things that could happen, all right? So, first thing, so I'm still in step 2. I'll do 2 part 1. If there are 4 terms, you're going to use a method called grouping. Okay? If there are 3 terms, you're going to use a method called the AC method. We're going to go through each of these, all right? And if there are 2 terms, it must be a difference of squares. That's the only thing we can work with. And then I'm going to put a question mark here because when you have 2 terms, you're hoping for a difference of squares. You won't always have a difference of squares. And I'll show you an example, all right? And that's it. I mean, that's like the basic idea behind factoring anything. Always try and pull a GCF, count the number of terms. You're either going to have 4, 3, or 2, and then these are the procedures for each one. Now, it is possible to get 5 or 6 or 7 terms, but not in this class. In this class, 4 is the most you'll ever see. If you were in a 14 class, that could go up to higher numbers, but here we stay at 4, all right? All right, so let's do some examples. We got those steps kind of set. You ready to see them in action now?
What's that last one?
Difference of squares, question mark? Yeah, like if you have it. We'll look at it. Okay, so it may seem weird to you that I started with 4 terms, then 3, then 2, instead of going 2, then 3, then 4. Did that seem awkward or no? No, doesn't seem awkward. Turns out that to do 4 terms is actually the cleanest one. And then to do 3 terms, you have to know how to do the 4 terms. So that's why we do it in that order. So let's start with our first example. And I'm just going to pull some problems here out of the packet. I have to pick these carefully right now because we can only do certain ones. All right. There we go. Okay. Everyone see that? Here we go. It's this one right here. 2xz plus 6yz plus x plus 3y. All right. So we're looking at this, and the first thing we want to do is GCF. Greatest common factor. So what do we mean by that? What we mean is we're looking at these terms. How many are there here?
3 more.
There's 4 terms. And the first thing you do is you look through and you say, is there a number? Is there a number that would divide into each of these numbers in front of these letters? So is there a common number that goes into all of those? So 1 is the only one, right? Right? Now, if 1 is the only one, then we ignore it. Okay, so we don't even worry about it. But if there's something other than 1, so like 2 goes into this, right? 2 goes into that, but 2 doesn't go into this and 2 doesn't go into that, right? So 2 is not a common factor. It's got to be common to all of them. 3 goes into this and this, but it doesn't go here and here. Agreed? So at this point, there's not something in terms of a number that's common to all of them, right? Do we agree with that? Okay, now you have to look at letters too now. So there's a single X here, right? And there's an X here. Those are in common, but we don't have an X here and an X here. So we don't have an X common through all of them, do we? How about Ys? Do we have a Y common through all of them? Not through all of them, right? Z's? No, right? So would you agree there's not a common number or any common letters through all of the 4 terms? Okay, so we have no GCF. No greatest common factor. So we're not going to pull anything out to start. Now, the second step was to count our terms. After we've pulled the GCF, how many terms do we have? Here we still have 4 terms, don't we? Okay, so we're now going to do grouping. So this means we're going to do grouping. Now, grouping is a technique, okay? And we need to make sure we understand how to do it. So here's the way grouping works. You write down your 4 terms. Okay, so I'm just rewriting the problem here. All right, and what you want to do is this. You want to go to the first term, go to the second term, and right after the second term, you want to draw like a little slash here, like this. And do it right after the last letter or number here. Do it before this sign right here. So draw a slash. And what we're doing is we're breaking our 4 terms into 2 pieces. Now, once we've done this, what you're going to do now is you're going to look at just these 2 terms like that's your entire world right there now. And you want to try and do GCF again, just on those 2. So looking at these 2 by themselves, what do they have in common? So they both have a 2, right? Like 2 goes into this and 2 goes into 6. So they both have a 2. So I'm going to write that down, 2. And they both have a Z, right? So I'm going to put a Z here. And what we've done is we've given ourselves what we call the greatest common factor. We've put it on the outside. And now what we need to do is come up with, don't put question marks here. I just want you to think through this. We want to try and figure out if we had a 2Z out here, if we expanded, if we multiplied this through here and then to another term, what would give us back these 2? Or if you don't think of it that way, think of it this way. If you take a 2 and a Z out of this first term, what's left? X. So right here, you put X. All right? If you take a 2 and a Z out of here, what would you be left with? So if you divide this 6 by 2, you have to divide, not subtract. So you're going to have 3, and then you pulled the Z out, so you'll have a Y. Now, you need one more thing, which is the sign between these. So this was a plus, this can be a plus. So just double check now. If you multiply this through here to here, would you get back those 2? That's what you want, all right? Make sense? Yes?
It kind of looks awkward because in the original term you have 2x and the x comes before the z.
Okay.
Is that going to mess up?
It doesn't. That's a good question. If I multiply through, I might get 2zx, and you're saying, is that the same as 2xz? Right? It is the same because multiplication is what we call commutative. So, if I ask you what's 3 times 5, that's always 5 times 3. When we do multiplication, the order doesn't matter. So these 2 multiplied is the same as them flipped and multiplied. Okay? So letters, only in multiplication is this okay, right? With addition and subtraction doesn't work that way. Well, addition it does, but subtraction doesn't.
Can you explain that one more time? You said just what's left, you put in the parentheses.
Well, there's kind of different ways to think about this. I think most of you seem to be like the idea that if we find our GCF and we say to ourselves, if we take this 2 out, right, and we take the Z out, what would still be here? Which would be that X. We put that here. It's a little harder for this one because we're taking a 2 out of this, so we're dividing it by 2. So that 6 becomes this 3. And then we take the z out, and so all we're left with is this y here. Does that make sense? Kind of, James?
Is that what you do every time too? Like every time you find your lowest number, you just divide it into the...
Yes.
Okay.
Mm-hmm. And if there's good news here, you can always check to see if you did it right by just multiplying it. You could do it on the side here. Just if you multiply this times this, do you get that? Yes. If I multiply this times this, so distribution, do I get 6, let's see, 6yz or 6zy, same thing. So that works, right?
Okay.
Okay. So we're only halfway there, all right?
Yeah.
The next step is to do the same thing on these two, all right? So now we're going to look at this, and we're going to look for a GCF. So is there a number that goes into both of these? Just 1, right? But we already said we don't really like to pull 1s out, right? I mean, it's like, what's the point? 1 times anything is itself. How about letters? There's no letter, right? So how do we do this then? Well, the ultimate goal, I should probably tell you what the ultimate goal is here. The ultimate goal is when you do this piece over here, you want it to be able to pull a GCF out, right? That's what we were trying to do. But really there's nothing here. What you want left in here, this piece, needs to match this piece exactly, all right? So do you recognize right now that this already matches this?
Yeah.
Okay, so I'm going to just place this here. Right now, that's still the same thing, isn't it? Like that's just me putting this here.
Okay.
These two match, but I need to have a GCF out front. I have to pull something out. You have to, in grouping, you have to pull something from each one. So I already heard people say the only thing that's in common here is a 1, right? I'm going to put a 1 out here, and I'm going to put a plus. So this plus symbol is coming from the idea that if I distribute my 1 through, think about a 1 coming here and a 1 coming here, we would get back this, right? If I put -1 here, then that wouldn't be the same, would it? Okay, so just take a step back, kind of reevaluate what we've done here. Originally, there was no GCF, so we moved on. We counted 4 terms. We went to grouping. Grouping said slash it right here, GCF out of this one, and then go to the second one, look for a GCF, but these two pieces have to match. So we put this down here, and that forced us to put a 1 out here. Okay, it had to be something, so we put a 1. Now, the next step. And this is the step that as long as I've been teaching has always been a problem. I think it's more of a problem for me than it is for you. Some of you have done this before, so who wants to tell me what the next line should be? Anyone?
Would it be 2z plus 1?
Okay, 2z plus 1 in parentheses. And then what?
And then x plus 3y.
X plus 3y in parentheses. That is correct. All right, so some students might have done that the other way around. They might have done the x plus 3y out here, and then the 2z plus 1 right there. That is the correct answer. But the reason why it's bothered me is because my question to you is, why is it this? Right?
Because the 2 and the 1 are on the outside of the parentheses?
Yeah.
I combine those 2 together?
But how are you combining those two together? This is the part that... So look, I'm going to show you something. I'm going to see if it helps. What if I wrote this down? What if I wrote 2z times m plus 1 times m? And I told you to look at that and factor out a greatest common factor. What do these both have in common? An m. So you would pull the m out, wouldn't you? You'd put an m out here, and then in parentheses, what would be in the parentheses to get back this when we multiply the m through? 2z plus 1, right? That's what you'd get? Okay. That's exactly what we're doing here. Exactly the same step. I'm going to erase this, even though this is correct. I'm going to erase this, and I want you to realize that we have 2z times m, right? This is like the m,
Okay.
plus 1 times m. So since these two match, what we do is we pull it out, just like we did here, right? We pulled that m out. So what is the m out here for us? What is the thing that matches? X plus 3y, right? That's what's pulled out. That's our m. And then in parentheses, we need the 2z plus 1, don't we? So we put the 2z plus 1. That is what's happening. Now, the answer you gave me, right? Who gave it? You, right? Is this answer reversed, right? Which is still correct because I just told you multiplication, the order doesn't matter, right? So a lot of students are taught that when you get to this step, all you have to do is put this and that in parentheses, and then just whatever was matching, put that in its own parentheses, and you're done. Which is that's the way it's taught a lot of times, but there's no like constructive idea of why it's that. All right, so hopefully that clarifies it. Again, I'm not going to try and undo what you have in your mind. If you can go from here to here and get it right, I don't care. All right, I just want to make sure you kind of understand that you can write it this way or flipped. All right, now we are done. So why are we done? What was the whole idea behind grouping?
Making sure that you can expand the problem and then get back to the original.
Yes, exactly. So if I were to multiply this together, you would FOIL it, wouldn't you? And if you FOIL this out right now, which we're not going to do, but if you FOIL this out, you will get this, okay? It will turn out to be this. What we've done is we've gone reversed and we've gone back, we've gone from this to this, all right? And that technique from here to here is called factoring, all right? Okay, let's do another one. You didn't realize today would be so fun, huh? Okay, let's try that one. 3x squared y minus 6x squared minus 3, oh shoot, hold on. Oh man, okay, let's just keep going. All right, first thing is what? What do we do first? GCF, okay? So I always like to start with numbers. Is there a number that, Gia? Is there a number that is common to all of the terms, Gia? 3, okay. Is there a letter that's common to all the terms? Just x, right? Now here you have two factors of x, right? X squared. Here you have two factors of x. So you could, at this point, pull out two factors, but this one only has one factor of x, right? This one only has one. So when you pull a GCF, you can only pull what they all have in common, which you were correct, only one factor of x. How about y's? No, there's only a y here and a y here. There's no y, no y. So the only thing we can pull out is a 3 and a single factor of x. Everyone good on that? Now, what's left, it has to be in parentheses. Now, notice how big I left that parentheses. I did that because I started out with 4 terms. So when I multiply this 3x through, to get back to that, I have to be able to go multiply through to 4 different things. So we need to fill in 4 blanks here. All right, so let's see. Rastim, you're up. Okay, so I'd like to know, Rastim, what this first term should be, and maybe you can help by explaining how you got it. So what would I need to put here?
XY.
XY, and that's it? Yes? Okay. And now, so how are you doing it? Just so everyone kind of knows how people are thinking about this. How are you?
From looking at the equation, like it's x squared.
Okay.
3x squared y. So we already have 3x.
We already have the 3x.
So what we need is what multiplies 3x and make it square.
Okay, so you have to make your x become a squared, so you brought in an x, and you needed a y, right? Okay, yeah.
And minus.
Oh, you can keep going. Okay.
Yeah.
All right. So minus
2x
2x
and minus again
xy,
minus y
just y. Okay.
plus 2x
Plus
plus y. Yeah, 2.
just 2. Okay. So that is correct. This step right here, again, is going to be different. You know, in everyone's mind, how you get this is going to be a little different. There is a way that you can do it. If you're really struggling with this step, if this is really hard for you, then here's something you can do, but you need to do it on the side. Now, I've seen some other teachers do it this way, and I don't really have a problem with it, but what you can do is you can divide each of these by the GCF. You can do that. And what happens is the 3's go away, x squared over x, one of the x's goes away. Make sense? And so what you're left with here in this first one is what? Just xy. Okay, here the 6 over 3 is 2, right? And then here one of the x's goes away. And so you're left with that, right? Now it's a minus, sorry. This was xy, sorry. And then here the 3's go away, the x's go away, all you're left with is minus y. And then here 6 plus 6 divided by 3 is 2, and the x's go away, so all you have is 2. So if you're really having trouble with this, trying to like just visually do it, then you can just do that little step on the side. Now you have to make sure your GCF is correct. If your GCF's right, that'll work. All right? We good with that? Mm-hmm. Okay. Laura K. Laura, you're next. So what would be our next step once we pull the GCF? What's the next step? Nope. Did you write the steps down? Okay, so just look at them. Too far down. We just finished step 1, right? Which was to pull the GCF. What's step 2? Oh, she said it. I didn't. Count the remaining terms. Count.
Is it count or is it grouping?
Well, count first, which means we have 1, 2, 3, 4. Since we have 4, it's grouping. Okay? All right. So that's our next step. And what will we do, Laura, when we do grouping? I said you're going to come in and slash this thing, right? Where do I slash it, Laura?
Before the minus y.
Right before the minus y. Perfect. Just there. Okay? Now, on this problem, we have a GCF that we pulled out, right? On the previous one, we did not. So the way we're going to deal with this is, like, this is our whole universe right now. This is where we're working. But we want to remember we still have this here, right? So the way I write this is I'm going to put 3x, parenthesis, close parenthesis, and now I start working with this. All right? And let's see. Luke, you're up. So how are you going to deal with that? What do I do next? I forgot. Laura said slash, and then I forgot what to do.
Alright, so now you would x times y minus 2, or x parentheses y minus 2, close it out.
Okay, so you're going to do a GCF on these, just those two. So you recognized already that you have an x in both these terms, so you put an x here. Then you said parentheses, that's correct. And then whatever we need to get this back. So this is going to be your y minus 2. So again, that step from here to here is going to be different for each person. How you do that. You want to keep going, Luke? Thank you for volunteering, sir. All right, so that you did this right. What did I say was the main goal of this step? What do we need over here?
You need to look
Like what?
the one you just did.
That's right. What part of that do I need it to look like? We need y minus 2 here, right? In order for this to work, this must be a y minus 2. Does everyone agree? So one way you can do this to kind of like cheat a little bit is just put a y minus 2 here and then ask yourself what would need to go here in order for this to work. So what would I put out here so that when I multiply it through, I get negative y and positive 2? I'd need a negative 1, right? In other words, what we're doing is we're factoring a negative 1 out of both of these. Okay? Yes or no? That's kind of a weird way to approach it. You do your GCF here, you figure out what that must be, you put it here, and then you ask yourself what this would need to be. -1 through here gives me negative y. Negative times negative would give me positive. So this works, right? David? I don't think David's here, right? Is David here? Luke, I threw you back into the pile, and I'm not sure why I did that. Marcus? Where's Marcus? Marcus, what's the next line going to be?
Oh, would it be the 3x parentheses?
Good, 3x. So we do not want to forget about that. 3x parentheses. Okay.
It would be y minus 2, but
Yeah, that's right. Okay. So this is the thing that we got in common, right? So you write it down. Okay, y minus 2, but we need it, we need it in parentheses, right?
And then
that minus 1.
We have in the next set of parentheses, we're going to have two sets of parentheses. We pulled this out, right? We pulled the y minus 2 out. And what's always going to be left are these two things together. Okay? It's those two together. So x minus 1 goes in here. So you know how I showed you a second ago with that m over here? That was just to help you see what happens, like why it's working. At the end of the day, the way that I would remember this is whatever you have matching here, you just write it down. And then whatever's in front of each of them, you put those in parentheses and you're done. You don't need to think through it any more than that.
so right there where you had the +2, like, so theoretically speaking, like, as long as your first part, like, so let's say it's y minus 2, so as long as it looks like that, like, you can automatically do that because you knew that like, you wanted to be the same as that, as long as the numbering difference.
That's right.
You can just switch up the.
Yeah, are you talking about how we wrote this down?
-1 I understand, but just when you made it like -2,
Uh-huh.
for a second it confused me. At the same
It was
time.
because I was trying to make it had to look like this. So I had to make it y minus 2. And then I was hoping that I could figure out a number here that would work. And -1 is the one that works. All right, we are done. We are done. We've completely factored it. We've turned this thing into a bunch of things that are being multiplied together, right? So we have factored. Okay, let's do another one. This one I think I'll make up. 5x cubed minus 2x squared minus 15x plus 6. Jared? Did I call you already? No?
Not today, no.
No, okay. Jared, first step?
You would look for the GCF, but
Okay.
I don't see one except for one.
Yeah, other than a 1, there's nothing else. There's no number that goes in all those, and there's not an x throughout all the terms. So we have no GCF here. So we move on to the second step. You want to keep going?
Sure. So you would group it.
Okay, grouping.
Yeah.
So grouping, because there's 4 terms. And then you want to pull a GCF out of the first 2?
I got x squared.
Yeah, so these two, the only thing they have in common is an x squared. So we'll do x squared out. And then what would be left in here, Jared, once you pull an x squared from both of those?
5x minus 2.
5x minus 2. Okay, good. I'm going to ask you to stop there. So Timothy is up. Next step. So I'm just curious to see how you want to approach this, Timothy. We've done this, and now we need to work on this second piece.
There's nothing to
So how do you want to approach it?
You could simplify it by 3.
Okay, by 3. So you're looking at this and you're just looking for a GCF. Is that what you're doing?
That's nothing.
But that's what you're doing. You're just looking at these saying, can I pull a GCF?
Yeah.
And that's one approach. But what is the ultimate goal?
To get it like.
To get it to look like this. So can I try and force you to try that again?
Yeah.
If this is a 5x, if this has to be 5x minus 2, then Timothy, can you come up with a number that you put out here that would distribute through to give you back that? So think about it for a second and see if you can think of a number that would multiply times this to give you negative 15x and then go through multiply times this to give you positive 6.
All I see is -3.
Negative 3, right? Negative 3. So if you make this a minus 3, negative 3 times positive 5x gives you negative 15x. Negative 3 times negative 2 gives you positive 6. Yes?
So,
I like that way of putting it there and trying to figure out what goes there. Yes?
no. So every time you do that, you can automatically just make it like the second
Yes.
part, and then just
And then go searching for that.
okay, yeah. That's pretty easy.
Because it is possible that you pull something out here, you do pull a GCF. Like Timothy could have pulled a 3 out, but it wouldn't have worked because this wouldn't have matched that. He had to pull a negative 3 out. And the only way he knows that really is by looking at what he's trying to get to, if that makes sense. Are we okay? Mm-hmm. All right. Christian, you're up. So what's next? Once we've gotten this to this point, what's the next line? There's really no work. We just have to write it down properly.
Yeah. So you're gonna put 5x minus 2.
Okay, in parentheses. And just one of them, right?
Yeah.
That's it, just one. And then
And then you're gonna put x squared minus 3 in parentheses.
x squared minus 3 in parentheses. And that's it. We're done. Okay. You will have to practice some more of this grouping on your own with the homework, but we need to move on. All right, so new problem. Let's try this. Don't let the x to the 4th power freak you out. Anissa? First step. GCF. Do you see our GCF? X squared. Okay, x to the 2nd power. This is x to the 4th, x to the 3rd, x squared. So you pull out only what they all have in common. So Anissa, if I pull an x squared out, I'm going to put a parentheses here. I should give myself enough room for 3 terms here, right? So you want to tell me what those 3 terms would be?
X squared
Okay, good.
minus
There you go. Okay, so again, that step right there, you can do it either mentally. It looks like you did it mentally. You might need to go write that thing on the side and then divide by x squared on each term. It's all going to depend on your comfort level with being able to visualize what just happened. So here to here is that, here to here is that, here to here is that. Okay, you're off the hook. Gabriella? What's next, Gabriella? We've pulled GCF, right? After you pull GCF, what do? No? So on the last ones we did grouping, right? Why did we do grouping? Because we had 4 terms left, right, when we did our GCF. So after you do GCF, what you have to do next is count your terms that are left. And what I mean is count these terms. We pulled the GCF, count what's in here. This time we have 1, 2, 3, right? So grouping is now off the table, all right? Now we have to have a different method. And so the method for this is called the AC method. Now there's probably a dozen different ways to teach how to factor this. And like I said when we started this, if you have a way of doing it, I'm not here to reteach it. But I have to actually teach it in a way that if you've never done this or you're not comfortable with it, I need to give you a method that will work, all right, moving forward. So you ready for the method? Mm-hmm. Okay. The method to do 3 terms is as follows. I'm going to do it on the side here. The whole goal is to try and break this down, right? Somehow factor that. So I'm doing this on the side like scratch work, and I'll come back and put my answer over here. So we have 3 terms, right?
Okay.
We want to make sure that it's what we call in descending order, which means you have to have like the highest power of x and then down. So like x squared, then x, then no x's, right? So it's descending order first. And now what you're going to do is you're going to look at the coefficients. So the number in front of this x squared is a 1. The number in front of this x is -3, and then this number by itself is -18. So you have 3 numbers here. Do you all see them? Okay. These 3 numbers are very important to this method. What we'll do is this. We're going to draw this little cross like this. It's not really a cross, it's like an X. Just follow me on this, all right? If you've never seen this, just do it and you'll see where we're going with this, all right? Okay, so I draw this little X, and then what I do is I take this first number and I multiply it times this number. I multiply them. So what is 1 times -18? -18. So right here, I put that right there. So just above it, just so you, as a reminder, you're taking 1 and you're multiplying by -18. That's how we're getting that number, right? Now, below that in this X, I'm going to just put this middle number, which is -3. Now, the only reason we do this is just to kind of help us have a visual construction of what we're trying to do here. All right, so we've got these 2 numbers now, -18 and -3. See these 2? Mm-hmm. What you have to now figure out is you have to mentally or on a calculator figure out, find 2 numbers that multiply to be -18, but also add to be -3. So you're trying to find 2 numbers that multiply to be this and add up to be this. So let's start thinking about numbers that do that. So I need to come up with 2 numbers that multiply to be 18, -18, right? So what about, like I'm just going to make a little list over here. How about 1 and -18? Wouldn't those multiply to be -18? Yes? Mm. But do they add up to be -3? No, they don't, right? So this wouldn't work. How about this way? Do those 2 numbers multiply to be -18? Do they add up to be -3? No. What would these add up to be? These 2? 17. This would add up to be -17. So this doesn't work. This doesn't work. So let me try something else. What else multiplies to be -18? How about 2 and -9? Right? That would multiply to be -18, but they don't add up to be -3, do they? So that doesn't work. I could flip it, make it -2 and +9, but that wouldn't work either because that would add up to be 7. I have to keep doing this until I get this to work. How about the next one? What would be the next one here? What else? 3 and 6. Now one of them has to be negative, right? To multiply to be -18, I have to choose one of these to be negative, but I need them to add up to be -3, right? So why don't we put the negative on the 6? Voila, there they are. 3 and -6, right? We've found the numbers. Now sometimes this takes time on a calculator or just writing out a list of numbers. But like I said, if we were working on this for like a month, we would get very fast with this